Hello, it's Chinero Anu here. In today's video, we'll be looking at the laws of indices and its interpretations. Without further ado, let's start learning. So let's look at the first law. The first law tells us how indices of the same basis can be multiplied. Now, if you take a look at this question, you're going to notice something. We have the same base here. We have an A here and we have an A here. So what this law is trying to say is this. Whenever you're multiplying indices of the same basis, here's what you do. Since they occur in the same basis, you simply pick one, alright, as we've done here, and then you sum up the index. You sum up this. So let me impute a number so that we can have a better understanding. So let's say we have 4 to the power of 3 times 4 to the power of 2. So what we simply do is pick one of the bases since they are the same number. So we're going to have 4 here, and then we sum up the index, okay, the exponent. We're going to sum them up. So we're going to have 3 plus 2 gives us, so we have 4 raised to the power of 5. This is another way we can understand this. If you have 4 raised to the power of 3, it means 4 times 4 times 4, right? Times 4 raised to the power of 2. 4 times 4. So how many 4s do we have here? Let's count it. We have 1, 2, 3, 4, 5. So that gives us the same answer. But instead of following this route, all we simply do is apply the law of indices and get this, which is much faster and easier. So how about the second law? Well, the second law tells us how to divide indices that have the same basis. In this case, we have A and A. It tells us that whenever we divide indices having the same base, we simply subtract their index. So what we're going to do here is, first of all, pick one of the bases since they are both the same, okay? And then we subtract the index. So we're going to have m minus n. So whenever you have to divide indices having the same base, all you do is to subtract their index. So let's impute a number to have a better understanding. So if you have something like 7 to the power of 9 divided by 7 to the power of 4, what we simply do is pick one of the 7s and then subtract the index, okay? So we have 9 minus 4, which is equal to 7 to the power of 5. That's simple, guys. Now, how about the third law? What does it say? It tells you how to multiply index by index, okay? In this case, we have the base and an index, all right, being raised to another index, okay? So what this simply tells us is that whenever you have this, all you need to do is multiply the index, okay? You simply multiply the index. So in this case, we pick A, which is already here, and then multiply the index. Let's take a look at an example. So if we have A to the power of 2 and then to the power of 4. For us to solve this, what we simply do is say A to the power of 2 times 4, and we're going to have A to the power of 8. Absolutely easy, guys. Another way we can look at this is to do this. Multiply A to the power of 2 times A to the power of 2 times A to the power of 2 times A to the power of 2. Remember our laws of indices, right? So when we do this, we will simply have A to the power of 4 plus A to the power of 4, which gives us the same answer. So in order to simplify things, we just go with this first method, okay? That's what the law of indices does. It comes to simplify numbers that have index up or exponents. So how about the fourth law? In the fourth law, it states that any number raised to the power of 0 is 1. So we have a raised to the power of 0 is equals to 1. Let's say a is 3. So 3 raised to the power of 0 is equals to 1. And even if it's a fractional number or a decimal number, when you raise it to the power of 0, it's still going to be 1. So one may wonder, how did they come about this? Let me show you a very quick equation that will help you understand this. First of all, we know that whenever we divide anything by itself, we have 1, right? For example, when we say 4 divided by 4, we know we have 1. 5 divided by 5, we have 1, right? So the same way, if we say a to the power of 3 divided by a to the power of 3, it gives us 1. Then from our knowledge of indices, we know that we can say a to the power of 3 divided by a to the power of 3, okay? So what we simply do is to write this base since they are the same, and we know from our knowledge of indices we subtract the index. So we're going to have 3 minus 3, right, giving us a to the power of 0. So we have used two methods to solve the same thing. So since they are the same, we can as well equate their results. Okay, so we are going to have a raised to the power of 0 equals to 1. So this explains why any number raised to the power of 0 is equals to 1. Having understood that, let's look at the fifth law. The fifth law tells us what to do when we have negative indices. If you remember, in my previous video, I spoke about negative indices, okay? In this law, we have a to the power of negative n. So here's what you do. First of all, we know that minus is the inverse of the operation plus. So we're going to have a positive n here, and we also know that multiplication is the inverse of division. That's why we have a division here. So let's take a look at an example. If we have 4 raised to the power of minus 2, okay, it's going to be 1 over 4. Remember, this becomes what? Positive, okay? The inverse of minus is plus. So that's why we have a positive 2 here. So it's absolutely easy, guys. Let's take a look at the sixth law. So the sixth law tells us what to do whenever we have a fractional index, okay? So here's what you do. Whenever you have a fractional index, you introduce the root sign, okay? And when you introduce the root sign, the denominator becomes the root inserted here, and while the numerator becomes the index, okay, that multiplies everything in the bracket. So if we have something like this, 8 to the power of 5 third is simply equals to 8, then we put the 3 here, okay? The denominator occupies this side, so we are looking for the cube root, and then we have raised to the power of 5. So the cube root becomes that number that when you multiply it 3 times, you get 8, which is 2, and then we have raised to the power of 5. So this is absolutely easy, guys. Now let's take a look at the seventh law. So the seventh law tells us what to do to get rid of an index, okay? So whenever one get rid of an index, what do? It simply tells us that we can get rid of the index by finding the square roots on both sides. That's the left hand side and the right hand side. So we're going to have square root of am is equal to the square root of n. Now let's impute some numbers here. Let's assume we are looking at 4 raised to the power of 2, okay, equals to the square root of n. So when you have this, when you find the square root of both sides, these 2 cancels these, okay? So you have seen we have succeeded in eliminating the square root sign. So we are going to have 4 is equals to the square root of n. So that's how we go about solving it. So this is it on interpreting the laws of indices. If you got value from this video, do hit the like button, subscribe if you've not, turn on that notification bell so that you can be notified whenever I upload videos like this. I do love to see you in the next video. Thanks for watching.